Hello, welcome to 9.2, Analyze Arithmetic Sequences, and 9.4, Arithmetic Series. Vocabulary. A sequence is an ordered list of numbers. Each number in a sequence is referred to as a term of a sequence, and so you'll have a first, second, third, ... The subscripts, these will be subscripts right here, refer to the position. So your first term will have a 1, so let's say it's 2. And then, I don't know, 4, 6. First, second, third term, and then ... So if you have an nth term, n minus 1 is the term before it, n plus 1 is the term after it. Then there's two different types of formulas. Number one is your explicit formula, which will look something like a sub n equals 3n. This is a formula that's always going to tell you what the nth term is with regards to its position. So this one is 3 times the value of n. So if you have 3, 6, 9, this is your first, second, third, and fourth term. So how do I get the first term? Well, multiply 1 first times 3. For the second term, 2 times 3. Third term, 3 times 3. That's an explicit formula. The other type is a recursive formula, and that is one that relates each term to the one, relates each term after the first term to the one before it. So if you have 3, 6, 9, 12, what do you have to do to 3 to get 6? Add 3. What do you do to 6 to get 9? Add 3. What do you do to 9 to get 12? Add 3. So each time to get the next term, you're just going to keep adding 3. So a sub n is equal to the term before it plus 3. Next thing I want to talk to you about is arithmetic sequences. So an arithmetic sequence is a sequence where the difference, where the difference between consecutive terms is constant. That difference is called the common difference. So if you're looking back over here, the common difference for 3, 6, 9, and 12 would be 3, because you're adding 3 each time. Alright, so a rule that I'm going to have you memorize is this one right here. This is for your explicit formula. A sub n is equal to the first term, a sub 1, plus n minus 1 times d. And remember, d is your common difference. Memorize this. We're going to use it right now. Actually, yeah, we are. First thing I would like to do for example 1 is to tell whether the sequence is arithmetic. If it is, write an explicit formula and a recursive formula. So it's arithmetic if there's a common difference. Is there a common difference? I think so. What am I doing here? What's the difference between 5 and 11? 6. So I need to add 6. To get to this one, I need to add 6 and then add 6 again. So yes, this is an arithmetic sequence. The next thing is they want me to write two different formulas. The first one that they would like for me to do is my explicit one, which I can use this to get to. Well, a sub n, my generic one, is equal to a sub 1. A sub 1 is your first term. What's the first term in all these numbers? 5. Plus n minus 1. I'm keeping this in n because I want the generic version. Times d, my common difference. What's my common difference? 6. So then if you distribute and then combine like terms, you'll find that a sub n is equal to 6n minus 1. That's explicit. Now for recursive. Well, what do we do from one term to get to the next one? So for a sub n, you take the term before it, which is a sub n minus 1, and then what do? I add 6. Yeah, typically people like recursive better because that's really all that you have to do. So explicit and recursive. Try part B, please, on your own. So take a moment, check my work with your work here. If we're looking at it, we have the difference was 15. My first term was 32. So I plugged in and I got a sub n is equal to 15n plus 17. My recursive one is a sub n is equal to a sub n minus 1 plus 15. In case you're having a hard time understanding, I'm saying a sub in a subscript n minus 1. Okay, for our next one, they would like for me to find the 15th term. Given a sub 8 is equal to 50, so the 8th term is 50 and the common difference is 0.25. Well, that handy dandy formula that's right above your paper there, we're still using it. So I'm going to plug in everything that I do know into this equation. Why? Well, I need to do a couple things. I need to be able to figure out what this is, but I'll need the a sub 1 in order to help me do what I need to do. So n minus 1 times d. Well, what do I know? Well, I know this. I know that the 8th term, so when n is 8, so n equals 8, I get 50. So this is the 8th term is 50, equals a sub 1, question mark, don't know what that is, plus n, well, n is 8, minus 1 times d. Well, what's the d? 0.25. So 50 equals a sub 1 plus 7 times 0.25. 7 times 0.25 is 1.75. And then when you solve it, you'll subtract 1.75. And you get 48.25 is equal to a sub 1. This, I think, is all I need. Let's check. What am I looking for? I'm looking for the 15th term. That's my goal. That's what I need in my life. So I'm going to go back to this equation right here, except now I'm looking for the 15th term. That's what I need. That's what I want. Well, let's find it. I want to find that I want to find a sub 15. Let's plug in what I know. So I'm going to go back to this equation. I know the first term is 48.25 plus n minus 1. Well, I'm looking for the 15th term. So now n equals 15. This is your n. So what's 15 minus 1? 14 times d, which is 0.25. Then you can use your handy dandy calculator, and you will get, when you add all this together, 51.75. So the 15th term is 51.75. Okay, so example 3 has a little bit of an old school flashback for you, but a couple things I want to remind you of. Number 1, that formula that's on the back side, I'm going to go ahead and write that here, so we don't have to flip back and forth. Now, we're given 2 terms. Given these 2 terms, they would like for us to write a formula, an explicit formula for them. And typically, if they don't tell you, unless they tell you otherwise, everything's going to be explicit. You're going to rarely be able to get away with just doing the recursive one. Yep, sorry to get your hopes up high. So plug in everything we know for each of these. So the first one, a sub n, the nth term, the 5th term is 10, equals a sub 1, question mark, plus n minus 1 times d. I don't know what the d is. I do know what the n is, though. What's the n? N is 5. That's a 5. So this is 10 equals a sub 1 plus 4d. Do the same thing with this term. So this would be 110 equals a sub 1 plus, well, we know it's n minus 1, so 30 minus 1, 29 times d. You have 2 variables and you have 2 equations. We can solve them. How do we solve this, Ms. Fitzgerald? I don't remember. Not a problem. Let's use elimination. So in order to eliminate one of the variables, I'm going to pick these ones, a sub 1s. I'm going to multiply by negative 1. And I get negative 10 equals negative a sub 1 minus 4d. This equation, I don't really feel like I need to change. I'm going to have 110 equals a sub 1 plus 29. Why didn't I need to change it? Well, because now if I add these 2 equations, I get 100 is equal to 25d. So d is equal to 4. That's great news, because now I have the d. What do I need? What else do I need? I need the a sub 1 as well. So let's plug in what I know. I'm going to go to this equation. 10 equals a sub 1 plus 4 times d, which I now know is 4. So 10 equals a sub 1 plus 16. So negative 6 equals a sub 1. Great. Now I can write what I need to write. So a sub n equals a sub 1, you said was negative 6, plus n minus 1 times d, which is 4. A sub n is equal to negative 6, distributing, plus 4n minus 4. A sub n is equal to 4n minus 10, or negative 10 plus 4n. That's my equation. Now, find the value of n for which a sub n equals negative 2. So a sub n, the nth term is negative 2, equals what? Well, I'm looking for the n. So 4n minus 10. Let's solve for n. N equals 2. That means the second term in this sequence is negative 2. All right, let's see. I think we will save this part for the next video.